Hi guys! Today we are going to be talking about angles and their measures. So this is going to be very similar to last lesson where we were talking about segments and their measures. So keep an eye out for new vocab phrases and for notation. Notation is going to be huge. All right, here we go. So an angle is formed by two rays with a common endpoint. This common endpoint is called the vertex. All right, make a note of vertex. We will be using it a lot. It's a point, so we're always going to call the vertex by the point, the letter that's right there. Now, the rays are called the sides of the angle. So, when we are talking about angles, we have the interior, the exterior, and the sides. The rays are the sides. Think Pac-Man. Anything inside the angle is the interior, anything outside is exterior. And just like with lines, it's not going to be kind of on the ray, it's either going to be on the ray or not. Or in other words, it's going to be on the angle or it's not going to be on the angle. Now, when we are naming angles, the big thing is that vertex. We're going to name the angle using 3 letters. And the important part of that is the middle letter must be the vertex. Now, there are actually 3 ways you can name an angle. The first one is with the 3 letters. So as we come over here, I could name this angle as angle ABC. Notice how B is my vertex and it is the middle letter of my name. I could also name this angle CBA. Again, B, the vertex, is the middle letter. The next way you can name an angle is with just the letter by itself. So I could call this angle B. Now, this name only works when there's only one angle on the vertex. So hypothetically, if we had another angle coming off the side like this, I could not use angle B to name any of these angles, because now there's multiple angles using this vertex and I don't know which one angle B is referring to. Which is why I like to call the 3-letter names the proper name of the angles, just because it's always going to be a very specific way of naming the angle that works in a lot of cases. Now, last but not least, when you are referring to the measure of an angle, you're going to use the lowercase m. So it looks right here. The way you say this is the measure of angle ABC is 60. Okay. Now, this should come as no surprise, this next part. When we are classifying angles, there are 4 different types. The first is an acute angle. These are angles that are less than 90 degrees. Next up, you have obtuse angles. These are greater than 90 degrees. Next, you have right angles, which are angles that equal 90 degrees. And then last but not least, we have straight angles. Straight angles equal 180 degrees. So when we are talking about classifying angles, we want to name the type. Now, for the most part, you can just observe and know the type. So you can look at an angle and know that it's an acute angle, or look at an angle and know it's obtuse or straight. Right angles are the exception to that rule. Okay? You cannot say it's a right angle unless you are told it's a right angle or you have this little 90 degrees box. But you have to have the information, you have to be told, or it's illustrated that's at a 90-degree angle. You can't just look at it and go, it looks 90. Okay, let's do an example. So for example number 1, as I'm going to name the vertex, K is the endpoint of both of those rays, so my vertex is K. And since the sides of the angle are created by rays, this is going to be KL, ray KL, and ray KJ. Make a note of the arrows, okay? Make sure we're naming our rays properly. Now, the three ways I can name this angle is angle LKJ. I could switch the front and the back letter and say JKL. And then since this only has one angle coming from this vertex, I could also say angle K. If I wanted to classify the angle, I can look at it. It's an obtuse angle. And that is the classification. Now you try. Do example 2 on your own. The video will pause for a moment. When it plays again, you'll see the answers. And how'd you do? Hopefully you named your angles with the vertex angle with the vertex letter in the middle. And just a bit of a notation note. Vertexes are a point, so they are named with a capital letter. In fact, everything should be capital letters here. Now let's move on and talk about congruent angles. Now, as a reminder, the definition of the word congruent is the same size and same shape. So make sure we know the definition of this word. Congruency applies to shapes, but it has a relationship with the measures. So if the measure of an angle A is equal to the measure of the angle B, as is the case in this picture off to the side, where both angles are 75, we then can say that angle A is congruent to angle B. And that would be how you would write it. Make sure you are writing the little m's in front of the angle whenever you are talking about the measure, and then, leaving it alone when you want to talk about the shapes. Now, if you want to illustrate congruency, what you're going to do there is you're going to draw a little half circle in the angle. These are the congruency marks for angles. Okay, here we go. More words. Now, angle bisector, perpendicular lines, and perpendicular bisectors are three really big topics. All right, we will be using these all year long. We introduce them here, and then we build off of it as we go forward. So please make sure you remember these words. Let's start with angle bisector. Now, we talked about bisectors last lesson. Remember? Bisectors are lines, segments, or rays that cut something in half. Okay, they're going to cut it into two equal pieces. So in this picture, an angle bisector is a ray that divides an angle into two congruent angles. I'm going to use a symbol, or if you want to write the word, either works. Now, in the diagram to the right, you can see an example of this where you have angle ABC, and it is being bisected by ray BD. Another way you can write this is that a ray BD is an angle bisector, and therefore angle ABD is congruent to angle DBC. And again, you can notice how there's the little congruency marks right here to indicate that those two angles are congruent. Now, perpendicular lines should be an old favorite of yours. You should know what these are. But just to refresh, perpendicular lines are two lines that intersect and they intersect at a right angle, and they also form right angles. Now, the symbol for perpendicular lines is the upside down T. And the way you would mathematically describe this picture over here is that line L is perpendicular to line M. And you can use the other line symbols for this as well, but this picture says L and M. So just remember the upside down T is perpendicular. Now, we learned about bisectors, we learned about perpendicular lines, and now we're going to put it all together. A perpendicular bisector is something that does both jobs. Okay, it is a line, a segment, or a ray, it doesn't matter which, that is both perpendicular to a segment and it intersects at the midpoint. And because it intersects at the midpoint, it is going to bisect the segment that it is intersecting. In the diagram to the right, line LM, make sure you have the hat, is a perpendicular bisector to segment PQ. And so if you look over here at the picture, you can see we have the right angle symbol. So we know that LM is perpendicular to PQ, and PQ has the little segments. So therefore we know that both pieces of that segment are congruent to each other. Okay, let's do an example. All right, so in this picture, you can see that there is multiple angles coming out from vertex B. This is why being able to name the angle is so important. You have to use all three so that we know exactly which one we're talking about. Now, we want to write another name for angle CBF. So CBF is right there. And another name for that could be angle FBC. Keep B as the vertex. Now, when we want to name the sides of angle EBD, remember the sides of an angle are rays. So EBD is right here. And so we're going to name the sides as ray BE and ray BD. Classifying angle ABC, well, ABC is right here, and that is in fact a straight angle. When we want to give an example of an obtuse angle, there are many to choose from. I'm going to pick angle ABF. Now, there are other examples. There are plenty that you could have picked from. Right off the top of my head, I can see EBC. So that would have been a good example as well. All right, next up, we want to name two congruent angles. So here I'm going to look for my little congruency markings in the angles. And there they are. So I've got angle ABE and angle FBC. Those are my two congruent angles. Last but not least, I want a perpendicular bisector. So I'm looking for both the perpendicular symbol and segment congruent symbols. So here is my perpendicular piece, and then here is my congruency symbols. So I want the bisector. I want the thing doing the bisecting. In this case, it's going to be ray BD. And make sure we notate that properly. And there you go. Now, I'm going to have you guys do number 4, and then when the video plays again, you'll see the answers. But I do want to make a small note. Earlier in the video, I said there were 3 ways you could name an angle. You have using 3 letters, you have using the vertex, and the last way is using these numbers that are inside of the angle. So sometimes when we have a big picture, like in example 4, the picture will put numbers in the angles as a faster way than writing out all 3 letters every single time. All right, that being said, go ahead, do example 4. The video is going to pause, and when it plays again, you'll see the answer. And here are the answers. All right. Next, we're going to talk about the angle addition postulate. Now, like the segment addition postulate, the angle addition postulate is when you add 2 pieces together and you get the whole. So you add 2 angles together and you get the bigger angle that it makes up. In other words, the way you properly write this would be the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. Remember to put the little measure symbol down because this is an equation and we are talking about the measures of those angles, so you need that symbol. So let's do some examples. In this first one, if the measure of angle ABD is 48, and the measure of angle DBC is 78, then find the measure of angle ABC. So piece plus piece equals the whole thing. So 48 plus 78 is equal to 126. So the measure of angle ABC is 126. Now, small note here as we go on to the next problem. Remember, it's the angle addition postulate, not the subtraction addition postulate. You always should start with the angle addition because that's the rule that we have. So when we have the measure of angle DBC is 74, and the measure of angle ABC is 119, that means this is what we're looking for. So setting it up with angle addition, we have x plus 74 is equal to 119. Now we can subtract, and x is going to be equal to 45. Or the measure of angle ABD is 45. All right, let's do one of the other examples. So in this one, everything is labeled, and that's always a good place to start. If you don't have a labeled picture, label it yourself. So we have the measure of angle PQR is 141, and that is the big angle. So all conditions for angle addition postulate are met. So we can do 13x plus 4 plus 10x minus 1 is equal to 141. This will simplify down to 23x plus 3 is equal to 141. Subtract 3 from both sides and you get 23x is equal to 138. X is equal to 6. Now I know sometimes you can do these steps in your head, but please remember to show me your plug-in steps. This is geometry. Part of the subject is making sure you can always prove where you got stuff. And that means showing your work. So the measure of angle PQS is going to be 82, and the measure of angle SQR is 59. All right, you attempt the next two problems. The video is going to pause. When it plays again, it'll show you the answers to number 4, and then it'll do the same thing for the answers to number 5. Good luck. Okay, here are the answers to number 4. All right, the video is going to pause again, and then when it plays, it'll show you the answer to number 5. And here's the answer. All right, let's keep going. Now, in this problem, you're going to need to remember your vocab. So if DEF is a straight angle, and the measure of angle DEG is 23x minus 3, and the measure of GEF is 12x plus 8, find each measure. So remember, a straight angle is an angle that adds up to 180, and that's how you get the information to solve this problem completely. So you can label these pieces, and then, because it's a straight angle, we can add them together, so 23x minus 3 plus 12x plus 8 is equal to 180. And so because we know our vocab, we get to set up the problem, and now we can solve from here. When we solve, we learn that x is equal to 5, and then when we plug in, we get that the measure of angle DEG is 112, the measure of angle GEF is 68, and then when you add those two measures together, you of course get the 180 that we knew from the beginning. All right, try number 7 on your own. When the video plays again, you'll see the answer. So when you solve, you get that x equals 7, and when you plug in, you get the measure of TUW is 38, the measure of WUV is 65, and then when you add those two together to get the big angle, you get a 103. Please, please, please remember to show your plug-in steps as you are doing your work. All right, now let's go over number 8. In this one, it's a bit more of a puzzle, and you got to remember your algebra skills. So if the measure of ECD is 6 less than 5 times the measure of BCE, and the measure of BCD is 162, find each measure. So we're going to break down this first part of the sentence. The measure of ECD is, okay, this is where your equal sign is. So we're going to need to write the expression that's equals the measure of angle ECD. To do that, I'm going to name measure of angle BCE x. And now we just translate this as an algebraic expression. So 5x minus 6. And now when we plug it into our picture, this angle is x, this angle is 5x minus 6, and it's a lot simpler to set up now that we can do the angle addition postulate. And now we can solve. So we got 6x minus 6 is equal to 162. 6x is equal to 168. And then x is equal to 28. When we plug in, because we want BCE, well, 28 for starters is BCE. And then when we plug in, we have 5 times 28 minus 6. And this is going to give us 134. So don't forget, there may be some problems where you have to translate it from a regular statement into an algebraic expression. All right, now last 2 problems. For these 2, we're going to use a diagram to our left, and I highly encourage you to annotate the picture as you do so. So in number 9, we have ABF is going to be 6x plus 26, and EBF is going to be 2x minus 9. It's a really bad arrow. There we go. And ABE is going to be 11x minus 31. So in case you can't see it, ABE is the big angle right here. So despite there being more angles in the picture, the thing we need is ABE. We have both of those pieces, so it's a simple angle addition postulate problem where we have 6x plus 26 plus 2x minus 9 is equal to 11x minus 31. And we can solve from here. When you simplify for x, or when you solve for x, you get that x is equal to 16. And then when you plug in to find the measure of angle ABF, which is the thing we're asked for, you get 6 times 16 plus 26. All of that is equal to 122. All right, now last problem. Now in this last problem, we have this very first sentence. If ray BD bisects angle CBE and ray BC is perpendicular to BA, which is a lot. So we're going to pause for a minute and just break down this first half and annotate this first part. So first up, BD bisects angle CBE. So BD is right here, ray BD, and it bisects the angle, which means that this piece is congruent to this piece. Next up, we have that ray BC is perpendicular to BA, so that means that this is a right angle. All right, and then we want to find ABD. So I want to find ABD right here. Okay, now I'm going to fill in for the other pieces. We know that angle CBD is 3x plus 25, and that measure of angle DBE is 7x minus 19. Because those angles are congruent, that means those measures are equal. So I can set those two things equal to each other, and that's how you're going to solve for x. So when you combine like terms, 4x is equal to 44, 11 is equal to x, which means I can now plug back in. But before we just plug in anywhere, let's look at our picture. We need angle ABD. We already know that this piece right here is 90. So all I got to do is plug into 3x plus 25, add that to 90, and then we have our answer. So 3x, or 3 times 11, plus 25. This is going to be 58. And then 90 plus 58 is equal to 148. And that is our final answer. And that's all there is to it. Let me know if you have any questions, and I will see you next time.